All right, welcome everyone. Today we're going to talk about we're going to start our AI module. And the way we're going to start our AI module is by talking about prompt engineering to begin with. Just a little heads up to the entire class. Currently, I could only see one person at a time, and I am down to one screen. So please make sure that you're raising your hand. I won't be able to monitor the chats as I usually am. So please just make sure to raise your hand if any questions comes up. All right. So before we start talking about AI and prompt engineering and everything else that dives into AI, the first thing that I want to do is I want us to understand what exactly is AI. It's important for us to know what's happening in the background or what is machine learning in general before we can actually start diving into utilizing this tool and why this tool is good for us. So the first couple of things that I want to clear up is that AI is a huge concept of machine learning. So I'll just go ahead and put ML there. Now, inside of machine learning, there is a couple of different models that we can create. The more traditional model that we're used to nowadays, or that everybody talks about nowadays, is a large language model, such as ChatGPT. We have Gemini now. There's a couple of other ones that are out there, but a large language model is one that you can actually talk to, give it sentences, and it's able to generate responses. Now, on the other side of that, there's machine learning that kind of has become a little bit less talked about because of its simplicity, but it is still very much a form of machine learning. These are called prediction models. Now, prediction models, inside of them, we are able to find such things like binary models, and we are also able to find things like multi-classification models. Now, binary models is something along the lines of, for example, we can all take a look at our phones, and our phones apparently know a little bit more about us than we know about ourselves. And inside of our phones, we can look at the description that our phone has for us. And from the usage and the things that you do within your phone, the sites that you visit, the actions that you take while your phone is in your pocket, because unfortunately your phone is listening to specific things, you can actually find in your settings a portion inside of your phone, or even I know there's a portion in Facebook that tells you what it is that is your preferred, excuse me, whether you're Democratic or if you're more on the Republican side, if you're more conservative, if you're more on the liberal side, there's an actual spot in your phone that's able to tell you, hey, from the posts that you like, from the things that you do, the input that we received from your usage classifies you into this portion. So a binary model would be something that evaluates to either 0 or 1. 0 being false, 1 being true. And all it is it takes in a series of conditions and then it's able to give you a um, a prediction whether something is going to come out to be true or false. A very good data set to work with. There's the potable water data set. You can find this on Kaggle, I believe. There it is, water quality and potability. So if we take a look at this water quality and potability, here's the different inputs that we receive. So in here, we receive characteristics of each water, where we have pH, hardness, solids, chloramides, sulfate, conductivity, organic carbon, uh, whatever that is, turbidity, and then finally we have our answer or our target variable, which is the probability. And if we take a look at the actual data set down below, let me actually make this full screen here. If we take a look at the actual data set down below, we're able to find that all the way on the right-hand side, for potability, we have a Boolean variable of zeros and ones. All right, we can scroll through this entire data set. In this data set, somebody went out there and conducted a study and actually collected all this information regarding different bodies of water for us to determine whether the water is actually potable or not. So that's a good example of of a of a binary model, right? It would take in this sort of input and be able to output true or false. Now let's take a look at a multi-classification data set. All right, so for a multi-classification data set, the good one that there is here is a students data set. Let me see that. I believe we can find that in here. There it is, student performance data set. All right, so for this one, in this data set, this is one that can make multiple different predictions. So in our example on the left-hand side there, when we were talking about binary models, what that model might look like would be where we receive a series of inputs or characteristics that gets fed into a model's neural network. And a model's neural network is essentially a bunch of tensors that are referenced to as neurons, where in every layer of these tensors, we're actually running some math to affect the weights and biases and change the actual value as we're working down through our neural network. So let me explain that here a little bit further. So here are our characteristics. This is our neural network where everything gets fed through. And then finally, our neural network will be able to output a value between 0 and 1. Right? So a value will be outputted between 0 and 1. That we can round said value to be evaluated between true or false. So we saw that already within the water potability. Now that neural network, what's actually happening inside of each independent neuron is we're taking a characteristic, we gave that characteristic some sort of mathematical value, and at each layer of this network, we're actually performing some math. We're not going to talk about the math that's actually going under the hood, but we're performing some math to change the value of each characteristic and relate it to its neighboring neuron. Through this math of calculating two neurons at a time, we're able to populate a child neuron. Now we continue doing this process where we compress it into we're able to output one singular neuron holding the value or a value between 0 and 1. Now a multi-classification model works a little bit different. We still have our characteristics that get fed into the neural network, but instead of having our multi-classification model only output one, our multi-classification model may have four different classes. Or maybe even grades. In this example, we have A, B, C, and D. Those are different grades that are available to us. And basically what we're doing is we're feeding it to our neural network. Our neural network is able to calculate characteristics, and then from there, it's able to output values. So for example, our neural network might tell us, hey, that if something is likely to be A, they might, after being rounded, their value would be closer to 4, whereas B's value may be closer to 3, and C's value may be closer to 2, and maybe D's value is anywhere between 1 and 0. And just like that, we're able to figure out from the characteristics of a student what kind of grade they would be able to achieve. Now let's see what that looks like inside of the data set. Well, in the data set, you can see here that I'm receiving a couple of demographic details about a student. The student ID really doesn't relate to anything because it's just a numerical number with no attachment to the characteristic of the subject. But instead, there's age, gender, ethnicity, the parental education, study habits, um, parental involvement, whether they're in extracurricular activities, and then finally their academic performance, right? Well, now if we come down to take a look here, all of those characteristics have a numerical value that has been attached to them. And at the end of it, or not at the end of it, excuse me, gender, parental absence, tutor, extracurricular. Oh, interesting. Huh.
Are you looking for the final output?
Seems like this one's missing the target value. Yes, I am. Interesting. It seems like this data set is missing the target value. But what we would receive is we would receive every single one of these, feed it through a model, and our model would be able to tell us what is the likelihood of a student achieving an A, a student achieving a B, or a C, like it tells us here. It tells us in grade class, but for some reason, I don't see it inside the CSV file. Interesting. Let me see what happens if I take a look at it here. There you go. So there is a grade class that's provided to us. We just weren't able to view it. So there's that grade class. We can see there's 2.0, 1.0, 4.0. So there's our multi-classification models, where from specific characteristics, we're able to receive a prediction. All right. Well, now that we talked about those two different types of models, these are mostly used kind of in the background within your site. You could use them for advertisements in general. So, for example, depending on what, I mean, I'm sure we all suffered from this one when you're on Instagram and you're scrolling through, and all of a sudden it feels like your phone is listening to you because as you're scrolling, it starts populating a bunch of advertisements of something that you said at some point. Essentially, what your phone is doing or Instagram is doing is it's running you through a model as a person. It's feeding all the characteristics, all the posts that you like, all the keywords that it was able to capture. And from there, it's able to output a series of ads that you're more than likely to click on or actually purchase something. And every time you click on one of those ads, well, you're reinforcing the algorithm to show you more and more of that information. Or even just in the post in general. The more you like something, the more you're going to get that information because the neural network that's working behind there is realizing, hey, this person is more than likely to spend more screen time or spend more time on the application if we are showing them this levels of content. And what it does is it alters through the levels of content by giving you something that's higher to your liking. Eventually, it'll start slowing down, and then right before it loses your interest, it tries to reset itself and give you something that's higher to your liking again so that you can stay on the application. All right, so there's our prediction model. There's a couple of little practical applications that we've talked about that you can utilize this for. Well, what about a large language model? Where can that be useful? Can anyone take a stab of a large language model that you've interacted with on a regular site?
Like customer support agents, like the chatbots.
The chatbots, customer support agents, those are the most popular ones, right? What a large language model is essentially one, a large language model gets determined a language. And the process for doing this, we actually feed them. So it gets fed not the entire alphabet, but gets fed a series of sentences. That kind of depends on the model that you want to build. If you want to build it super specific and super dynamic, then you would feed it words. If you want to make it more or less dynamic and less specific to the user, then you would feed it sentences. And what the process would look like in the background is where the machine would give each word or sentence a numerical value. And it does this because it's a machine. It's not able to actually talk to us in words. It's not able to actually understand us. But what it is able to do is it's able to conduct math and provide numerical output. So that means that when I tell ChatGPT, hey, what day is it? Although that's what goes through the user interface, what ChatGPT sees is something along the lines of 1.34, maybe 578.3, and then 2, 1, and maybe a 0.0001, right? So there's the what ChatGPT actually sees in the background inside of that learning model. This is what gets fed into the neural network is a series of numbers where every number is interpreting a word or a sentence. And then what ChatGPT likely splits out is something along the lines of a series of numerical numbers again. And that series of numerical numbers probably introduces into today is the 25th. And what happens is the user interface takes the time, or maybe they leave it inside of the model itself before the response from the model comes back. They turn this series of numbers back into words. And this process is called tokenization, where we give numerical values to characters or series of characters. That way we can translate English or whatever language we are feeding the model into something the machine can utilize to learn and speak through and work with, and then translate their output into something that us as humans can read. All right, so that's a quick introduction into the different types of machine learning there is out there. There's definitely a lot more out there that you can learn about machine learning. We're just scratching the very surface after today, as of today. All right. Does anyone have any questions over this quick overview of machine learning? If no one has any questions, then let's actually dive into our lecture for the day. Let's take a look at some actual content here. All right. So intro to prompt engineering. Can I get somebody to read that first paragraph, please? And let me actually zoom in a little bit. There you go.
Which one? Intro or what is prompt engineering? Or
What is
both?
prompt engineering?
What is prompt engineering? Prompt engineering refers to the practice of carefully crafting input instructions or queries to achieve desired outputs from language models like GPT-3.5. This process involves experimenting with different formulations, structures, and keywords to elicit specific responses. Prompt engineering is a valuable strategy when users seek precise or tailored information, generate creative content, or fine-tune the model's behavior for particular application. However, caution should be exercised in its use, as excessive manipulation may lead to biased or undesired outcomes. Additionally, prompt engineering might not be suitable for tasks that require the model to learn and generalize from diverse inputs, as it can compromise the model's ability to provide unbiased and contextually appropriate responses. Striking a balance between guidance and allowing the model to exhibit its inherent capabilities is crucial when ensuring responsible and effective use of prompt engineering.
All right. Awesome. All right, and then it talks about different types of learning language models that we have here. So there's the base learning language model, which we have GitHub Pilot, essentially from a series of characters. It's able to make a prediction as to what the next series of characters will be, right? GitHub Pilot doesn't actually have some sort of prompting that you can do with it. You can leave comments and say, hey, what I'm about to build down below will be an API interface. And GitHub Copilot will know that you're working within Python or within Django or within whatever server like structure it is you're working with. And it will try to generate some code from you, but you can't actually directly prompt GitHub Pilot. ChatGPT is something that's instruction tuned, meaning that I can actually define information to ChatGPT. I could give it limitations as far as its output as well. I can ask it questions regarding my code and specifically tell it at the end, do not tell me the right answer. I just need you to tell me this specific characteristics about my code. This is what I'm looking for. All right. So there's a key difference between instruction based and base LLMs. All right. Can I get somebody to read this capabilities portion here?
Capabilities.
Customization. Oh,
Oh,
you got it.
now you got it.
Customization for specific tasks. Instruction-tuned LLMs can be fine-tuned to excel in specific domains or tasks. This allows prompt engineers to customize the model's behavior to meet the requirements of a particular application, making them versatile for various use cases. Contextual relevance. These models can generate contextually relevant responses based on the provided instructions. By carefully crafting prompts, prompt engineers can guide the model to produce outputs that align with the desired context or information. Adaptability to user preferences. Instruction-tuned LLMs can be tailored to respond in ways that align with the user preferences or the tone required for a specific application. This adaptability enhances user experience and makes the models more versatile. And for improved performance in specialized tasks, fine-tuning allows for improved performance in specialized tasks or industries. For instance, a model fine-tuned on medical language can provide more accurate and domain-specific information in healthcare applications.
All right. Fantastic. Now let's talk about some limitations here. So sensitivity to input formulation. Instruction-tuned LLMs may exhibit sensitivity to the formulation of input prompts. Small changes in wording or structure can lead to different outputs, requiring careful consideration by prompt engineers to achieve desired results. Potential for bias. Like all language models, instruction-tuned LLMs can inherit and perpetuate biases present in their training data. Prompt engineers should be aware of this and take cautions or precautions to mitigate biases when crafting prompts and evaluating model outputs. Lack of real world understanding. While adept at generating contextually relevant text, these models may lack a genuine understanding of the world. They operate based on patterns learned during training, which may result in responses that appear sensible but lack true comprehension. So challenge with ambiguous queries. Instruction-tuned LLMs can struggle with ambiguous queries or situations where additional context is needed. Prompt engineers should be mindful of this limitation when designing prompts, providing sufficient information for the model to generate accurate responses. All right, and then it starts talking about some good practices and some bad practices here. But instead of going through this process of just running these queries, we're going to learn by actually utilizing prompt engineering to create an application today. We're going to try to recreate what we did last week in our full stack week inside of ChatGPT through a series of prompts. And we'll learn through that series of prompts how important it is for us to be super specific with the way we write our prompts. With that said, currently right now it is excuse me, it is 9:31. Let's go ahead and take a quick, let's call it 14 minutes, and then we'll come back at we'll come back at 9:45 and continue on with our lecture. Thank you so much, everyone, and I'll see everyone back here shortly. All right. Now that everyone has returned, let's go ahead and continue this portion of our lecture. So before we go into good and bad practices about AI, let's actually put this into some practical application here. Now, common mistake that people make with AI when they're first utilizing it to try to do some sort of prompt engineering is they try to go straight into it, right? They try to just say, hey, I want to um, build a full stack application that will render a list of 5 students. Right? We could just give ChatGPT something like that, and here it goes into, hey, here's a full stack app. It's giving me Django with React and Axios, giving me an API endpoint for students, and it walks through the process of installing it. It's giving me quite a bit of work here, so it tells me to go into installed apps and ask REST framework and create an app named students, which we can see we start the app here. All right, it gives me a model, which we talked about when we created our databases with SQL Alchemy. It gives me a serializer here. And then it gives me an API view to return these 5 students. All right, gives me the portion for the students. Great. Looks like everything there is good as far as like including URL patterns, so the URLs are attached. And then it gives me this migrate portion. But inside of this migrate portion, they also add this script here for creating some students. And it looks like you create 5 students utilizing Django framework itself. Then with Vite and React, it's able to create this application. Now, I've utilized, it looks like I've utilized AI enough, and I am currently signed in to where it was able to give me a pretty decent answer because it knows the kind of work I do and the kind of pattern that I follow whenever I ask questions. I'm sure that if someone else is out there trying this out and you just put build a FS app that will render a list of 5 students, it may give you a completely different answer. Maybe it chooses to use a different stack with like Node.js. So let's try to make this application a little bit more dynamic. Let's say this prompt here, right? Currently, right now, we have this prompt saying, hey, build me an application with 5 different students. Let's change it up. So here we're going to talk about prompt engineering. And let's go over prompt one. So in prompt one, this is our prompt. And the return that we receive, we received an application in Django, Vite, React. No database was attached, and a model was provided. All right. Well, let's say for prompt two, what should we do for prompt two? All right. And first, we determined that the tech stack that it was providing was wrong. So let's try to clarify that. Let's say, hey, I want you to build a full stack application that will render a list of 5 students. And then we could say, comma, this application should be built with the following tech stack. We could specify we want HTML, JS, CSS, specify we want a Flask server, and a PostgreSQL database. All right, let's see what happens when we run this through the AI here. All right, so now it tells me here's how you can build a full stack student list application using a front end, which is HTML, JavaScript, a back end, which is Flask, and a database, which is PostgreSQL. So now it's even providing me a project structure, something that it didn't provide me before. It tells me, hey, here's an app, here's something called static, and here's something called templates. So it looks like this time it's building it so that Flask will be rendering my HTML process. And that's fine. I didn't define that I want to utilize live server to render my HTML. So there's my issue there with my prompt. All right. Now let's start looking through this. So it tells me through PostgreSQL, here's the setup. So it gives me a nice little schema that I can utilize to PostgreSQL. It gives me a command that I can use to execute this schema. Then it tells me how I could connect utilizing PsychoPG. And it looks like even though it tells me how to connect utilizing PsychoPG, it never utilized Flask SQL Alchemy. Instead, it just does it through PsychoPG in itself. Okay, so that's not necessarily what we wanted to do, but it is getting pretty close as to what we want our application to look like. Just a little bit more clearing. So let's go ahead and define that here. So now that we told it our tech stack, it provided a application folder structure. It gave us HTML templates to render the information, but it rendered our front end through the Flask server. It made 0 API calls to our Flask server. There is no fetch being utilized. And it also failed to utilize Flask SQL Alchemy to connect to the database. Right, so there's a couple of things that we missed out on there. All right, so here's our current prompt that we sent out. Right now it is 9:54. Let's go ahead and take until 10 o'clock. And what I would like the class to do is to take this prompt and build your own prompt, right? I would like somebody to provide me at 10 o'clock their own engineer prompt that I can run through this AI service. And then we'll run it through the service and we'll see what kind of response we get back from ChatGPT. So currently right now it is 9:54. I'll see everyone back here at 10 o'clock with a prompt ready to go. Thank you so much, everyone. All right. Oh, I stole a minute from you guys, but that's okay. Welcome back, everyone. Now that we are back, let's go ahead and take a look at a prompt that one of you has built. Can somebody please send me their prompt either through Slack or through the chat, preferably through the chat, please? That way we can run it through the AI model. All right, got one from Daniel. Let's go ahead and pass this through the AI here. Let's see what we got. Okay, so in our third attempt, we got with PostgreSQL, Flask using Python, JavaScript, CSS, and HTML, build me a database that contains 5 students utilizing pSQL. Then using that database, create a render on HTML using that DB through fetch commands to Flask display this on a HTML with CSS. I want this full stack application to be all connected and talking to each uh, application specified. All right, let's see what comes out from this prompt here. All right, so absolutely below is a complete full stack application using PostgreSQL, Flask, with Fetch. All right, so it looks like it's still giving me the same app there and a little bit of a project layout. All right, so there's PostgreSQL with 5 entries. Gives me a command to enter everything inside of pSQL. Now it gives me Flask, PsychoPG, course. All right, still failing to utilize SQL Alchemy. There it gives me the ability to look for some information, and we can see that get students route is working there. All right, so for my front end files, it's utilizing static. And there we can see the document is grabbing for the API students, fetching for the response, and then adding the response using JavaScript. All right, awesome. We're getting closer and closer to what we want here. Let's go ahead and take this prompt and redefine it. All right, let's take it to the next step. So let's step it down, break it down step by step this time. Instead of giving it just one rendering, I'm gonna say, hey, build a full stack application meeting the following tech stack and development conditions. And there I'm gonna break it down for the model. I'm going to say, what I want you to build is, for example, our front end hosted on live server, VS Code extension. I want to render an HTML file with CSS and a JS script. Upon rendering upon rendering index HTML, main.js will make an API call utilizing fetch to grab an array of 5 student objects. Main.js will then manipulate the DOM to generate an unordered list where each list item will represent each student. Let's run this portion here just to see what it comes up with. All right, let's type it in there. Send it through. All right, so now it gives me an overview. It never gave me an overview before. All right, so my prompt is getting more extensive, so the answer that it's able to provide for me is getting more extensive as well. So now it looks like the student app is broken into two separate files. We have our app.py that has all of our database schema stuff, and then it has front end. I don't expect anything within the backend portion to change because I didn't give it specifications yet. So nothing there has changed. We're still not utilizing SQL Alchemy. That's okay. But let's take a look at our front end. Our front end now has a relationship to a style sheet. It has a script tag linking us to main.js. We can see a little bit of CSS has been added. And now our document has an event listener where it won't render index HTML until this content is loaded. That's what this DOM content loaded means. We're going to fetch for the API here. We'll receive a response. We'll grab the student list element and then generate a list item for each one of those students. All right. So there's our fetch, which we're waiting for with that dot then, and then grabbing those students that are now in JSON format to render them. So our front-end application looks a lot better now. All right. Does anyone have anything that they would like to add to the front-end portion of this prompt before I continue breaking it down? Okay, I'm not seeing any hands up, so let's go ahead and take it to the next portion here. Well, now that I have my front-end application specified, let's specify the database schema. Let's say database hosted locally on port 5432 with PostgreSQL. And actually, we could just specify PostgreSQL database hosted locally on port 5432. Now, this database name will be school, and it will hold a table named student. This table should allow for the following columns. There should be an ID, a first name, a last name, an age, and a grade. I believe that's everything we have inside of our student CSV. So that's what we'll leave it to. Now, generate an SQL script that could be executed from within Postgres in PostgreSQL to create a database and the table described. To then add 5 student entries. All right. So now let's go ahead and take that, run it here in our application again. So now it's giving me a summary of requirements there. Now it's giving me more information. Now there's a database name and students that has been generated. All right, and here it is. So I can create database school, connect to school, create the table students, and do my database entry there. All right, so now I have a little bit more information. We can see that my pSQL command has actually changed quite a bit as well, so that I can just run this from the command line. That's great. But now let's fix this Flask portion. Finally, let's talk about our backend server. So following this pattern, what would be my prompt for the backend? Can anybody take a stab at building this other than Nick? No stabs.
Can you ask the question again, please?
Yeah, absolutely. I want to build the back end instructions. So what to do with Flask? What would that look like?
I guess I would want Flask to pull the information from the database, um, and make instances of each student to be stored. Am I going in the right direction here?
I think I'm grabbing your general idea here. But maybe we should get some more input. And I see Scotty has his hand. Do you want to tag Scotty in, Andy?
Yeah, go ahead, tag in.
All right. What do we got, Scotty?
Maybe label it like you did your other ones. Back end. Um, Back end utilize a Flask server.
Right. So utilize a Flash server.
Um, uh, Config the Flask app to utilize Flask SQ Alchemy
Okay.
and Psycho PG.
So let's put Flask server will interact with the PostgreSQL database utilizing SQL Alchemy. And
Well,
what following?
Flask Alchemy, and then also use Post or Psycho PG to connect or I guess talk with each other.
Encyclopedia. All right, so Flask server will interact with the PostgreSQL database utilizing Flask SQL Alchemy and Encyclopedia. Okay, awesome. So now we got a little bit more interaction there, and we specified how we're going to talk to it. Anything else we want to add in there?
Create a model for the student table.
All right, a model of the students table should live within this server.
Create me a route that will interact with my students model and query all students.
API endpoint that will grab all students from this model. All right, let's break it down. Let's see what comes up for our backend when we run this prompt. Go ahead and run this prompt. Let's see, we're asking for a complete full stack application utilizing PostgreSQL, Flask, SQL Alchemy, Cycle PG2. So there's a little bit of a difference there because all we did was specify Cycle PG, HTML, CSS, and JS. So there's fetch, Flask, SQL Alchemy, object relational mapping, Cycle PG2 driver. All right, so there's our PostgreSQL script. We can see the database of school. Everything there has remained the same. Now we can take a look at our Flash server. So now it's changed considerably. Now we have backend and app models and config and requirements. Let's take a look at what this looks like. So in configuration, we're specifying a, it's asking me if I want to hide this inside of a .env file to create, basically hide my user keys. We're not going to be doing this, but it's giving me my Postgres URI there. So that's awesome that I'm able to interact with that. There we can see it's able to create our alchemy It creates the table for students, and it even has a built-in serializer for to dictionary. All right, so there's a to dict method that will take itself and churn this model into a dictionary. In the app, we can see that app comes in. We have a configuration from object, which reference to config. Let's see where we're importing config from. So import config, which is this file here. So we're importing that entire file. Interesting. All right. Then we're initializing our database. So there's a little, I'm pretty sure this line right here is wrong. But we'll see if it works. Then it's able to initialize our database with an app, course. We never once mentioned course, but it was able to allow that for us. And then it creates our route of API students, which is able to get students of limit 5 dot all. So there's a little bit of an issue there. Never once did I tell it to limit, but it's limiting for me. And I was able to grab all. And then we have index HTML and everything else being rendered. All right, let's take a look here. It's not giving me a command to start everything, it looks like. But that is okay. Let's start generating this folder structure here. So I'm going to come over. Don't really need main.py, so I'm going to remove main.py here. I'm going to start creating that project. Let's do school project. Going to change directories into that school project. In there, I'm going to create a front end. I'm going to create a back end. We can see that I still have, so there's my front and back end. I still have this dot default activated, which it looks like it actually activated twice. I'm gonna deactivate and then activate again. All right. Now inside the school project, I now have a backend and front end directory. So I'm gonna change directory into front end, and in there I'm gonna make my index.html. I'm gonna make my main.css and make my main.js. I'm gonna bring in all of that content that was provided for me. So here's main.js. Let's bring that in. All right, I can tell there's already a couple of issues here, but that's okay. Let's bring in that CSS. And let's bring in that index HTML. Awesome. So there's our three separate files there. All right, let me do a little bit of cleanup because I don't want all of these to be opened. Now in my backend, there I was told that I would have an app.py. Let me take a look at my folder structure that it gave me here. Told me I need a models.py, config.py, and requirements.txt. Okay, so let me do touch models.py, touch config.py, and then requirements.txt, which we'll do here shortly. So now it told me to install the following. So I need Flask, pip install Flask. All right, I need to install Flask SQL Alchemy. All right, so now that's been installed. Now it wants me to install Flask cores. Okay. And then finally, PsychoPG. And I know that's wrong, so I'm going to do Psycho PG binary here because we want to utilize Psycho PG3, not Psycho PG2. All right, so there's Psycho PG being installed. Good. And now I can pip freeze requirements.txt. And now requirements.txt gets created here with everything required to run this Flask application. All right. Now let's start filling in our files. The first file that we have here is our database. So let me go into our config file and fill in all those blanks there. Actually, we could leave it as such and this would work. Let me see, PostgreSQL, database user, there is no password, host, port, and then database name. Okay. So host is good. There is no password, so let's remove that password portion there. All right. And we'll see how this goes as far as our actual application being able to render. So there's my config file. Here's my models. All right, there's our database SQL Alchemy, our model in itself. Finally, our actual app. All right, let's execute this. Let's start off by executing our app. Let's do Python app.py. All right, so it looks like I'm getting a couple of errors here. The first one that I'm getting is, hey, CyclePG is not a module that's being installed and it's not working. Well, we know we actually did install CyclePG. So there's probably an error somewhere inside of our instructions. So let's clarify our instructions for this learning model a little bit more. All right, our backend utilizing Flask. Let's talk about this. So our backend will be a Flask server hosted locally on port 8000. All right, so Flask will utilize SQL Alchemy and make sure that we do Flask SQL Alchemy to interact with the database school and create a model for the data table students with a toDict method to serialize student objects. All right. Now, within the configuration, ensure to specify that Psycho PG3 will be utilized in the database URI. Once that has been connected, I want to create, I'll say finally, generate an API endpoint that will query the database to grab all students and return said students as a list of dictionaries. All right, let's see what this does for us. You know what? It's gonna be easier if I do it this way. Boom. All right, we send our request one more time. So now let's take a look at this HTML stack here. So now it's telling me HTML, CSS, JS, fetch server with live server. Awesome. Getting all this great information here. There's my project structure, which I totally forgot about this init school DB. So let's go ahead and create this as well. Oh, it wasn't done being created. All right, let me copy that one more time. Okay, so that looks like it's gonna work. We'll see if it does here shortly. All right, we already did this binary portion, so now I switched us to SQL to PG3. And now we can look at the database URI, and we're also including this plus PG, which we didn't have before. So let's go back over here, make sure that makes it into our configuration. Okay, great. Everything else remained the same. Students is still the same. Our app, I believe, has changed a little bit here in that configuration process. So let's go ahead and make sure that we change our app now. All right, we can see that now it's running on port 8000. This DB create all seems a little interesting here. Um, okay, so now we're tracking the modifications. We have the get students, which grabs all of the students, and then it's able to turn them all into a dictionary before returning it as a response. So this server looks more correct now. It's actually an API that's able to work. It looks like it's utilizing course, even though I never specified course. Nothing within the student body changed with the exception of this API call. Now the API call is going to port 8000 within my localhost. So let's change that inside of our front end as well. All right. Okay, so now it's giving me the correct information. Let's make sure that this database command will actually work. So let's make sure that the database works here. I'm within that init school DB. Let me post that command there. All right, so init underscore school DB, that works. Localhost, port 5432. My user, which is Francisco Avila. All right, so PSQL, Francisco Avila dash H. Okay, this should work, right? Let's go ahead and try to run this command. All right, so I made a database of school. It tells me now I'm connected to school as the user Francisco Avila. I was able to create a table and I inserted 5 different students there. So let's do PSQL school, select all from students, and there we can see our 5 entries of 5 separate students. All right. So now through AI, I was able to create that database schema. That database worked. Let me change directories here and go into the backend and now run Python app.py. See what happens now. All right, so it looks like we have a little bit of an error. Let's take it out. So it looks like PG, there was a connection failure. 127001, port 5432 failed. Your user does not exist. Let's take a look at that. Looks like it's a problem in my configuration. That's because I utilized your user instead of Francisco Avila. Let's try it again. And now we have an actual API running. Great. If I try to open that up, we get this not found portion. And if I go to slash API slash students, oh, it looks like that still didn't work. Interesting. Let's take a look at our app. That is definitely our URL pattern that we have there. Okay, there you go. So it looks like that closing slash was the issue. So I need to make sure I add that there. So we had an issue within our patterns there where it didn't give me a closing slash. I had to add it myself. So now I know that the closing slash will take me to the correct URL pattern. But now I have an API running with Flask that's interacting with a PostgreSQL database and returns 5 separate students. Okay, great. Now I've myself written zero code up to this point, but I did have to have a fundamental understanding about how these things work in order to guide AI to the proper solution. All right, so there's my initial DB, there's my configuration, I know my models work, and now the moment of truth. Let's take a look what index.html does here. And of course, I don't have the live server extension here. Oh, go ahead, Aaron.
It's looking for a different name for your CSS file,
All right, let me take a look
either
here.
main or style, one of those two.
All right, currently I'm installing that. And while that's being installed, let's take a look at index.html. It is looking for style. So let's change that to main.css. Great catch. Nick?
If I knew your IP address, could I query that database that you're currently running locally?
If I was hosting this on an actual public server, you could, but because it's all living inside of my machine, you can't. Right? I'm not in any way connected outside of my machine. So you can't really enter it. But if I was hosting it inside of like AWS and I'm publicly releasing and doing videos like this, then yes, anybody would be able to query that database and do some pretty mischievous stuff to it. All right. Any other questions? Awesome. Well, let's do our moment of truth here. Let's go live on live server with index.html. And it gives me a fantastic display here. Right? I gave it almost zero to no instructions on my front end. But when my front end renders, you can actually inspect. And from inspecting, I can take a look at my network tab. And you can see that there is, oh, let me refresh it. You can see that there is a call in main.js where it's making a request. So there you go. There's main.js. Now here's where it's making the request for students. And students object comes back and then it renders on my screen. All happening under 30 milliseconds inside of my machine. And just like that, we have our week's work where we were able to create a full stack application with HTML, JavaScript, CSS, and a Flash server. Now, I don't want anyone to take this lecture from today and think to themselves, oh, well, why am I learning this? You're essentially teaching me that AI is gonna eventually take over our jobs. That's not the case at all, right? A random person or someone who doesn't have the background that we have or the background that we have learned in the last couple of weeks wouldn't be able to generate an application like this. Or maybe they would, but it would take them almost the same amount of time that it took us to create it from scratch. Now, why, you may ask? There's a considerable amount of background knowledge that we need to know in order to generate a good prompt. This prompt here took us a various series of tries. We've been prompting this AI model for the last 45 minutes, right? Rather, I'm purposely making some mistakes to make sure that we can demonstrate the process of how prompt engineering works, right? Prompts have to be specific. They can't just be open-ended, and we can't leave the AI network to just pick up our lack of knowledge. We ourselves have to be educated in the topic. Because we're educated in this full stack process and how everything is connected, we're able to create a prompt that will successfully run and execute the purpose that we want. The way I'd like to think about prompt engineering is essentially another form of coding. You're still coding, you're just not, you're going through the process of coding, which is grabbing a problem, breaking it down to its smallest factor, and then figuring out how to tackle that smallest factor one step at a time. The only difference is that rather than solving it through literal code, you're solving it by researching good code, right? What's the difference between this and me going on Stack Overflow and asking Stack Overflow, how do I do this? And then looking at specific blocks of code to then copy and paste them and alternate to fit what I want them to do. Well, that's essentially what we're doing. We're just doing it faster through ChatGPT. And that's the point of prompt engineering. It's not to replace your ability to code or to replace engineers. It's to help you be able to code faster, be able to generate applications, and improve your performance. All right. Does anyone have any questions regarding prompt engineering or how we went about this process of creating this prompt? Let's hear it, Michael.
So, as somebody who has tried, I haven't been good at using AI, so I don't use it too often, but as somebody who sees it as a tool, I feel like conflicted on when in my like learning journey to start implementing it as a tool versus kind of grinding away at coding the hard way, I guess.
That's a great question. So when it comes down to this, I like to think about it in the more elbow grease you put in up front, the better it's going to be. So while we're in the program, I would strongly recommend to utilize AI as little as possible. Um, my reasoning behind this, it's important for everybody here to truly understand how things work and how they're connected, right? If you're constantly prompting AI to create templates for you or to generate code for you, that fundamental understanding of how things connect to one another, or being able to identify, like the way it was able to provide me a Postgres or a database schema URI, and just from looking at that URI pattern, I was able to say, oh, this is wrong, right? That fundamental understanding is important before you can truly use AI to boost your performance, right? So what I would say is try to do 2 weeks behind. So for example, OOP, that's 2 weeks behind us now, right? We understand classes and we understand how classes talk to each other. And at this point, everybody here has a pretty good experience interacting with classes. So if at any point you want to just generate classes or you're trying to generate models quickly and you don't want to write it from scratch, you could definitely run that through AI and say, hey, I need you to make these models that meet the following expectations, right? And 2 weeks from now, if you need some help with something in JavaScript that will make an API call, you could just tell AI, hey, I need you to create something with JS that will conduct the following API call, right? Because at that point, it's been 2 weeks of you experimenting with this tool. You have the fundamental understanding of how it works. So you could identify when the AI process is misleading you and you could correct it. Does that answer your question, Michael?
That does, thank you.
Of course. All right. Any other questions? Perfect. If there aren't any other questions, I'm going to go ahead and stop the recording here.